Well, this video is for Math 95. It's for the assignment on solving rational equations, which are equations that involve algebraic fractions. So we had kind of an introductory assignment to these types of equations, and this is a follow-up. The equations here are going to be considerably more complicated, but we will use the method that allows us to generate solutions for them. So let's take a look at problem 2 and talk about what we're going to do here, and then we'll talk about how to do it, and then we'll do it. All right, so let's see here. We've got 5 over t squared minus 9 equals 3 over t plus 3 minus 2 over t minus 3. So the general process for solving these equations is that what we want to do is get a common denominator, okay? So that's the first thing. And if you look at this, the denominators, these two are prime, they can't be factored. This one factors into the product of the other two. This is going to be our common denominator right here, t squared minus 9, because this is t plus 3 times t minus 3. So this one's not going to change. This fraction is not going to change. Over here, I'm going to multiply this fraction by t plus 3 over t plus 3, and multiply this one by t minus 3 over t minus 3. Okay? So again, this one doesn't change. We're creating a common denominator that's equivalent to that is t squared minus 9. So what we come out of this with is 5 over t squared minus 9 over here. Here we'll have 3 times t minus 3 minus 2 times t plus 3 over t squared minus 9. I mean, maybe I'll write it so that it looks exactly the same, but this is our common denominator. Okay, now the next step is key to this. Because we're dealing with an equation, we can clear out this denominator by multiplying on both sides by t plus 3 times t minus 3. So these will cancel, and we'll come out of this with 5 equals 3 times t minus 3 plus 2 times t plus 3. And this is a very simple linear equation. Let's see here. So 5 equals 5t minus 3. 5t is 8. T is 8 over 5, or 1.6. Okay. So again, that's the general idea here, is that we're going to get an equation that has these denominators. One of the denominators is going to be our common denominator. Okay? And then we're going to turn the other two into that common denominator by multiplying in the appropriate places. Alright? And then once we get that set up, we're going to cancel out the denominator and just take what's in the numerators. Alright, so that's problem 2. Let's look at a couple more. Problem 6 is, the denominators are very similar to what's happening in problem 4. So let's take a look at problem 6. 3a over a squared minus 2a minus 15 minus a over a plus 3 equals 2a over a minus 5. So again, these two denominators are prime. They can't be factored. This one is factorable, and it factors into the product of the other two denominators. So this is our common denominator right here, a squared minus 2a minus 15, or, as I'm going to be writing it, a minus 5 times a plus 3. So this fraction's not going to change. It's going to stay the way that it is. These other two fractions, we're going to create a common denominator that equals this. So this one needs to get multiplied by a plus 3 over a plus 3. And and this one gets multiplied by a minus 5 over a minus 5. Okay, so on this side we get 2a times a plus 3, and then on the bottom a minus 5 times a plus 3. Over here we get 3a minus a times a minus 5 on top, and a minus 5 times a plus 3 on the bottom. Now, we don't want to do any canceling. You can cancel these, but that would eliminate the common denominator. Over here you can't cancel these, and so that's why we won't do it. But what we can do is to multiply on both sides by a minus 5 times a plus 3. And then that'll cancel out the denominator. So we'll end up with 3a minus a times a minus 5 equals 2a times a plus 3. Okay. So now we just need to put this in standard form. Distribute the a in here, distribute the 2a in here. And let's see, we'll add that to both sides. So this is 8a, so we're going to need to subtract 8a on both sides. That'll cancel out these. So, we want to subtract. Subtract 8a. There we go. So this will be negative 2a and positive 3a squared. And I think that's it, equal to 0. So factor out the a, 3a minus 2. So a could be 0, or 3a minus 2 could be 0, which means a would be 2/3. Okay, so that's number 6. There's not too many. There's only 10 problems on this page. So let's go ahead and look at 8 and 10 and see how those work. So you see, sometimes with these problems, you get a quadratic equation out of it. Sometimes you get a linear equation out of it that only has one solution. But either way, it's good. It's important that you know how to solve each of those equations, the linear and the quadratic. Okay, problem 8. 2 over y minus 1 minus 7 over y plus 4 equals y over y squared plus 3y minus 4. Okay? Very similar setup to the previous problems that we've looked at, right? You've got these two denominators here and here that are prime, can't be factored. This one is factorable, and it factors into the product of the other two. And that's going to allow us to create a common denominator without too much trouble. Okay? And there are other situations where the denominators don't work out neatly like this, and that creates a little bit more work. We're not going to look at that type of problem. We're going to focus on these. Okay, so we're going to create this common denominator here. This one needs to get multiplied by y plus 4 over y plus 4, and this one gets multiplied by y minus 1 over y minus 1. So what do we get out of this? So we get 2 times y plus 4 minus 7 times y minus 1, and then we've got our denominator here, y plus 4 times y minus 1. On the other side, this was already our common denominator, so we didn't change anything. It's still y over y plus 4 times y minus 1. And then we cancel out the denominators. Multiply on both sides by y plus 4 times y minus 1. These cancel, we come out of this with 2 times y plus 4 minus 7 times y minus 1 equal to y. So, 2y plus 8 minus 7y plus 7. Let's see, negative 5y plus 15. Add the 5y to both sides. 15 equals 6y. 15 over 6 is going to be see, I think that is 2.5. Okay. So there's problem 8. Again, we got one solution out of that because we ended up with this nice linear equation. It's much easier to solve than a quadratic equation. I think in problem 10, we may run into a quadratic, but we'll take a look at it and see. That's the last one on the last problem on the assignment here. All right. And n over n minus 4 plus 7 over n plus 2 equals 8 over n squared minus 2n minus 8. So that's going to be our common denominator, n squared minus 2n minus 8. Okay? This is factorable, and it factors into the product of these two binomials right here, n minus 4 times n plus 2. All right, so like I said, this is going to be our common denominator. This fraction is going to stay the same. We're going to leave it alone. Over here, we're going to create this common denominator for these two fractions. This one gets multiplied by n plus 2 over n plus 2. This one gets multiplied by n minus 4 over n minus 4. So, this will be n times n plus 2 plus 7 times n minus 4 over our common denominator. And on the other side, we'll have 8 over n plus 2 times n minus 4. And then we're going to cancel these out. We're going to cancel out this denominator by multiplying on both sides by n plus 2 times n minus 4. So, n times n plus 2, 7 times n minus 4 equal to 8. All right, let's see here. Well, n squared plus 9n minus 28 equals 8, so this will be minus 36. N squared plus 9n minus 36 equals 0. Now you can run this through the quadratic formula if you'd like to, but it is factorable. This could be n plus 12 times n minus 3, right? So there's our positive 9n in the middle and a negative 36 on the end. So this says n could be 3, and over here, this one says n could be negative 12. Okay, so that's it for this assignment. There will be a problem on the final similar to this one. So, as always, if you have any questions about this, please let me know. Thanks.